A data center is a facility used to house computer systems and associated components, such as telecommunications and storage systems. It generally includes redundant or backup power supplies, redundant data communications connections, environmental controls and various security devices. Large data centers are industrial-scale operations using as much electricity as a small town. History. Data centers have their roots in the huge computer rooms of the early ages of the computing industry. Early computer systems, complex to operate and maintain, required a special environment in which to operate. Many cables were necessary to connect all the components, and methods to accommodate and organize these were devised, such as standard racks to mount equipment, raised floors, and cable trays. A single mainframe required a great deal of power, and had to be cooled to avoid overheating. Security became important, computers were expensive, and were often used for military purposes. Basic design guidelines for controlling access to the computer room were therefore devised. During the boom of the microcomputer industry, and especially during the 1980s, users started to deploy computers everywhere, in many cases with little or no care about operating requirements. However, as information technology operations started to grow in complexity, organizations grew aware of the need to control IT resources. The advent of Unix from the early 1970s led to the subsequent proliferation of freely available Linux-compatible PC operating systems during the 1990s. These were called servers. As time-sharing operating systems like Unix rely heavily on the client-server model to facilitate sharing unique resources between multiple users. The availability of inexpensive networking equipment, coupled with new standards for network-structured cabling, made it possible to use a hierarchical design that put the servers in a specific room inside the company. The use of the term data center, as applied to specially designed computer rooms, started to gain popular recognition about this time. The boom of data centers came during the dot-com bubble of 1997 to 2000. Companies needed fast internet connectivity and non-stop operation to deploy systems and to establish a presence on the internet. Installing such equipment was not viable for many smaller companies. Many quantify companies started building very large facilities, called Internet data centers, which provide commercial clients with a range of solutions for systems deployment and operation. New technologies and practices were designed to handle the scale and the operational requirements of such large-scale operations. These practices eventually migrated toward the private data centers, and were adopted largely because of their practical results. Data centers for cloud computing are called cloud data centers. But nowadays, the division of these terms has almost disappeared and they are being integrated into a term, data center. With an increase in the uptake of cloud computing, business and government organizations scrutinize data centers to a higher degree in areas such as security, availability, environmental impact and adherence to standards. Standards documents from accredited professional groups, such as the Telecommunications Industry Association, specify the requirements for data center design. Well-known operational metrics for data center availability can serve to evaluate the commercial impact of a disruption. Development continues in operational practice, and also in environmentally friendly data center design. Data centers typically cost a lot to build and to maintain. Requirements for modern data centers. IT operations are a crucial aspect of most organizational operations around the world. One of the main concerns is business continuity. Companies rely on their information systems to run their operations. If a system becomes unavailable, company operations may be impaired or stopped completely. It is necessary to provide a reliable infrastructure for IT operations, in order to minimize any chance of disruption. Information security is also a concern, and for this reason a data center has to offer a secure environment which minimizes the chances of a security breach. A data center must therefore keep high standards for assuring the integrity and functionality of its hosted computer environment. This is accomplished through redundancy of mechanical cooling and power systems serving the data center along with fiber optic cables. The Telecommunications Industry Association's TN 942 Telecommunications Infrastructure Standard for Data Centers specifies the minimum requirements for telecommunications infrastructure of data centers and computer rooms, including single-tenant enterprise data centers and multi-tenant Internet hosting data centers. The topology proposed in this document is intended to be applicable to any size data center. Telcordia GR 3160 NEBS requirements for telecommunications data center equipment and spaces provides guidelines for data center spaces within telecommunications networks, and environmental requirements for the equipment intended for installation in those spaces. These criteria were developed jointly by Telcordia and industry representatives. They may be applied to data center spaces housing data processing or information technology equipment. The equipment may be used to operate and manage a carrier's telecommunication network, provide data center-based applications directly to the carrier's customers, provide hosted applications for a third party to provide services to their customers, provide a combination of these and similar data center applications. Effective data center operation requires a balanced investment in both the facility and the housed equipment. The first step is to establish a baseline facility environment suitable for equipment installation. Standardization and modularity can yield savings and efficiencies in the design and construction of telecommunications data centers. Standardization means integrated building and equipment engineering. Modularity has the benefits of scalability and easier growth, even when planning forecasts are less than optimal. For these reasons, telecommunications data centers should be planned in repetitive building blocks of equipment and associated power and support equipment when practical. The use of dedicated centralized systems requires more accurate forecast of future needs to prevent expensive overconstruction, or perhaps worse, under-construction that fails to meet future needs. The lights-out data center, also known as a darkened or a dark data center, is a data center that, ideally, has all but eliminated the need for direct access by personnel, except under extraordinary circumstances. Because of the lack of need for staff to enter the data center, it can be operated without lighting. All of the devices are accessed and managed by remote systems, with automation programs used to perform unattended operations. In addition to the energy savings, reduction in staffing costs and the ability to locate the site further from population centers, implementing a lights-out data center reduces the threat of malicious attacks upon the infrastructure. There is a trend to modernize data centers in order to take advantage of the performance and energy efficiency increases of newer IT equipment and capabilities, such as cloud computing. This process is also known as data center transformation. Organizations are experiencing rapid IT growth, but their data centers are aging. Industry research company International Data Corporation puts the average age of a data center at 9 years old. Gartner, another research company, says data centers older than 7 years are obsolete. In May 2011, data center research organization Uptime Institute reported that 36% of the large companies it surveyed expect to exhaust IT capacity within the next 18 months. Data center transformation takes a step-by-step approach through integrated projects carried out over time. This differs from a traditional method of data center upgrades that takes a serial and siloed approach. The typical projects within a data center transformation initiative include standardization, consolidation, virtualization, automation and security. Standardization, consolidation. The purpose of this project is to reduce the number of data centers a large organization may have. This project also helps to reduce the number of hardware, software platforms, tools and processes within a data center. Organizations replace aging data center equipment with newer ones that provide increased capacity and performance. Computing, networking and management platforms are standardized so they are easier to manage. Virtualize. There is a trend to use IT virtualization technologies to replace or consolidate multiple data center equipment, such as servers. Virtualization helps to lower capital and operational expenses, and reduce energy consumption. Virtualization technologies are also used to create virtual desktops, which can then be hosted in data centers and rented out on a subscription basis. Data released by investment bank Lazard Capital Markets reports that 48% of enterprise operations will be virtualized by 2012. Gartner views virtualization as a catalyst for modernization. Automating. Data center automation involves automating tasks such as provisioning, configuration, patching, release management and compliance. As enterprises suffer from few skilled IT workers, automating tasks make data centers run more efficiently. Securing. In modern data centers, the security of data on virtual systems is integrated with existing security of physical infrastructures. The security of a modern data center must take into account physical security, network security, and data and user security. Carrier neutrality. Today many data centers are run by Internet service providers solely for the purpose of hosting their own and third-party servers. However, traditionally data centers were either built for the sole use of one large company, or as carrier hotels or network-neutral data centers. These facilities enable interconnection of carriers and act as regional fiber hubs serving local business in addition to hosting content servers. Data center tiers. The Telecommunications Industry Association is a trade association accredited by ANSI. In 2005 it published ANSI Tier 942, Telecommunications Infrastructure Standard for Data Centers, which defined 4 levels of data centers in a thorough, quantifiable manner. Tier 942 was amended in 2008 and again in 2010. Tier 942 Data Center Standards Overview describes the requirements for the data center infrastructure. The simplest is a Tier 1 data center, which is basically a server room, following basic guidelines for the installation of computer systems. The most stringent level is a Tier 4 data center, which is designed to host mission-critical computer systems, with fully redundant subsystems and compartmentalized security zones controlled by biometric access controls methods. Another consideration is the placement of the data center in a subterranean context, for data security as well as environmental considerations such as cooling requirements. The German Data Center Star Audit Program uses an auditing process to certify 5 levels of gratification that affect data center criticality. Independent from the ANSI Tier 942 standard, the Uptime Institute, a think tank and professional services organization based in Santa Fe, New Mexico, has defined its own 4 levels. The levels describe the availability of data from the hardware at a location. The higher the tier, the greater the availability. The levels are the difference between 99.671%, 99.741%, 99.982%, and 99.995%, while seemingly nominal, could be significant depending on the application. Whilst no downtime is ideal, the tier system allows for unavailability of services as listed below over a period of 1 year. Tier 1 status would allow 1,729.224 minutes or 28.817 hours. Tier 2 status would allow 1,361.304 minutes or 22.688 hours. Tier 3 status would allow 94.608 minutes or 1.5768 hours. Tier 4 status would allow 26.28 minutes or 0.438 hours. The Uptime Institute also classifies the tiers in different categories.